Hello everyone. In this video we'll see or learn about the notch filter, which is used in periodic noise reduction. So a notch filter, it is a frequency domain filter which is designed to remove the periodic noise that appears at specific known frequency. Now here, unlike the band reject filter which remove the entire band of frequencies, a notch filter, it will remove or reject only very specific frequencies or specific frequency points or the narrow regions, and a notch filter, it rejects or passes the frequencies in predefined neighborhoods about a center frequency. Now, due to the symmetry of the Fourier transform, the notch filters must appear in symmetric pairs about the origin in order to obtain a meaningful result. So, the shape of the notch area, it can also be arbitrary, that is, it can be rectangular in shape. Now, why we use notch filter? Because the periodic noise such as the interference, that is the interferences from the electrical noise or the signals, then scanner lines, repetitive pattern noise, such as sinusidal noise, these will appear as the bright spikes in the Fourier transform at the predictable positions. So this notch filter, it will zeros out all the bright spikes. So because of this reason, we will be using the notch filter. Now, these are the applications of the notch filter. That is, it is used in removing the sinusoidal noise, then fixing the line interference in the scanned images, and clearing the vertical or the horizontal striping. And it is also used in removing repetitive machine vibration patterns. So this is the transfer function of the filter for ideal notch filter. So here the ideal notch filter, it will remove the frequency near the noise peak, okay, and also it sharp the boundaries which causes the ringing attack. Then second type of notch filter is the Butterworth notch filter, and this is the transfer function for that. So it is the most commonly used filter or the commonly used notch filter, and here you have dk of u comma v, which is the distance from u comma v to the noise peak. Okay, so here one more thing you have is d of minus k. Here you can see it is only dk, and here it is d of minus k. So this is the distance from the symmetric peak. This d of minus k, it is the distance from the symmetric peak. And this Butterworth notch filter, it will smoothen the images, and it doesn't have any ringing effect, and also it is best option for the periodic noise reduction. Third type of filter, notch filter, is the band reject filter. So here this is the transfer function for Gaussian notch filter. So here it is the smoothest response of all these filters, and here it preserves the details like extremely well, and these are preferred for videos and high quality images. Okay. Next we have the steps for this notch filter. So the first step is you have to compute the Fourier transform of the image. Second step is you have to identify the periodic noise locations, that is usually the bright symmetric spikes. Then you need to construct notches at those locations using one of the types of the filters. Either it may be ideal or Butterworth or the Gaussian. Now you need to multiply the Fourier spectrum with the notch filter, and the last step is you need to find out the inverse Fourier transform in order to get the restored image. These are the steps for notch filtering. So this was about the notch filter. Thank you.